Hi, I'm David Feldman. I'm your instructor for math, or stat actually, sorry, 105. Um, so this is an online course. As I said in my email to you, which you should have received by now, um, it's my first online course that I've taught, so I'm going to try to do some kind of lecturing by posting things to YouTube. So this is my first attempt at that, and we'll see how it goes. So I think normally what I'd be doing is I've got a blackboard in my office, and I might write some notes up there and that sort of thing. Right now I'm just getting set up. I've got a new office, so I won't do that part of it. You can see I've got boxes and the blackboard's on the wall. But for now, let me just tell you a little bit about statistics and what it's about. Statistics is basically about what you do when you have a lot of data, how you draw conclusions from that data. It might be conclusions about the value of a particular unknown. It might be conclusions about whether your assumptions about the value of a particular unknown are reasonable or not, that sort of thing. And let me give you a couple of examples just to give you an idea. So for example, say I want to know how much I weigh. Okay, so I get on a scale and I weigh myself. Okay, now if we assume that my weight is constant, which is probably not a very good assumption, it's not even clear exactly what you mean by my weight. You know, do you mean my weight in the morning? Do you mean my weight with enough food in my stomach? That sort of thing. But let's make the assumption for the moment that my weight is constant, so I'm not gaining or losing weight. I still may have different measurements of my weight during the day, right? As I said, it depends on the content of my stomachs and that sort of thing. So, so what are you going to do with all those different numbers? Is one of them my actual weight? Is there such a thing as my actual weight? You know, so what we're going to do is we're going to assume that there is some number that is my actual weight, maybe my weight with an empty stomach or something like that, and then we'll take the several measurements, and usually you'd look at some kind of what's called a statistic to estimate the value, the true value of the thing you're looking for. So you might use a statistic like the average, the mean of the various measurements you make, or the median, or, you know, and it all depends on what purpose you want to use the statistic for. But basically that's what you'll do. And so what you have to ask yourself are questions like, well, how much data do I have to collect to get an accurate answer, an accurate number, an accurate measurement? Do I need to measure once? Is that accurate enough? Or do I need to measure 5 times and take the average or the median or whatever you're doing? Do I need to measure 100 times? You know, how much data do I need to collect? So those are the kinds of questions you address in statistics. You also might ask a question like, is my assumption about my weight reasonable? Like, suppose I assume I weigh under 165 pounds or something like that, which is probably not true. But anyway, let's make that assumption. And I might measure it and measure my weight one day and say, well, it's actually 166 pounds that. So does that mean that I'm actually over 165, my true weight, or what does it mean exactly? Or is it did I just eat a lot or something like that beforehand? So those kinds of questions. And usually what we're assuming is that there's some kind of noise or randomness in the data that we aren't able to account for except in a statistical manner. Okay? And I'll give you one more example of a statistical type question, just because it's kind of interesting and amusing, I think, anyway. I like this kind of thing, though. The other example I'll give you of a statistical type of question, there's a Tom Stoppard play called Rosencrantz and Guildenstern Are Dead, and it was made into a movie. And in it, the two characters, by the way, Rosencrantz and Guildenstern, if you don't know this, they're two minor characters in the play Hamlet by Shakespeare, and Tom Stoppard wrote a whole play about them where they're the central figures. But it's kind of, there's some kind of irony going on there because they're actually, part of their role in the play is being minor characters in Hamlet. So, and it's a little bit about that play between them being the central figures of this play, but minor characters in the background play, for if you like, for Hamlet. Anyway, in the opening scene to Rosencrantz and Guildenstern Are Dead, one of them, and I don't remember who, is flipping a coin over and over again, and every time he flips it, he gets a head. Obviously, in the real world, this is a pretty unusual event. I mean, you know, if you flip a coin 100 times in a row, you'd expect not to get all heads. If you were getting all heads, that would be very significant. Okay? And in fact, that's the sense in which this is a statistical example, because the significance of it, if you were getting all heads, is that you'd say, hey, this cannot be a random event with 50-50 odds of getting a head. Because if it were, there's no way I would flip the coin 100 times in a row and get heads every time. Okay? And so you'd be able to draw a statistic. Now, that's actually not quite true, because there is a way, if you flipped a coin 100 times in a row and got heads every time, there is actually a chance, if you flip a coin 100 times, there is actually a chance of getting heads every time. Let's see, the chance is 1 over 2 to the power 100. So 2 to the power 100, 2 to the 10th is about 1 in 1,000. So 2 to the power 100 would be about 1 over 1,000 to the 10th. So that would be 1 over 1 with 30 zeros after it. So it would be, you know, let's see, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, something like that. 29 zeros. So it's 29 zeros and then 1. 0.000. That would be the chance of that, or yeah. Anyway, obviously very remote. So what do you conclude if you flip a coin 100 times and get heads every time? Well, a reasonable person would probably conclude A, that the coin is fixed in some way, right? However that might be. I don't know how you fix a coin. Maybe it's a two-headed coin. That might be worth checking out if that happens to you. Or B, that they're characters in a play. Well, maybe a reasonable person wouldn't conclude that, but that would be the correct conclusion for Rosencrantz and Guildenstern. They don't conclude that. I think that might be kind of Tom Stoppard's joke, that they should be concluding that, because he's a very mathematical playwright. Anyway, I think I've rambled on enough. You've got an assignment to get underway on. You know, I should have probably called this up before I did this, but I'm going to call it up right now so I can tell you what your assignment is. Hang on a second. I'm just going to my copy of the outline. Oh, right. You know what? Go to the Moodle site. Check out what your first assignment is. You'll have some reading from Chapter 1, some problems to try. At some point during the week, there's a discussion page on the Moodle site, and at some point during the week, I'm going to ask people if they have any questions about the assignment. And I think the Moodle page will be a good place for us to have discuss questions about how the assignment's going and that sort of thing. Well, I'm feeling like I'm almost ready to make this a wrap. Please feel free to contact me if you like. My office is in Sentinel Wing on the Castlegar campus of Selkirk College. 215 is the office number. If you're not able to go there, you can email me at, I think I'll write it down on my blackboard as I say it, if I can find a piece of chalk. Like I said, I'm just moving in. Oh, here's colored chalk. That'll work. So you can certainly email me at dfeldman at selkirk.ca. Okay, I'm not sure if you can see that. Let me see. Well, hopefully you can. Alright. And then my office phone is 250-365-1331 if you need to call me. And then there's all this stuff about please move this board, but as you can see, I'm moving in and things are a little interesting in my office. Well, that's about 10 minutes. Maybe 10 minutes is a good length for a introductory video. Wish you well with the class. Oh, you're seeing my ceiling. There we go. Wish you well with the class. Hopefully I'll get better at this YouTube thing. Alright. Thanks. Bye.